Alright guys, I am going to walk through a few of these. Remember, this should all be done, but we will be turning it in at the end of the chapter. So let's start with number 5 here. It says a compound contains 37.7% sodium, 23.0% silicon, and 39.3% oxygen. So remember, we're going to pretend like we have a sample that has a mass of 100 grams, because that then will give us a ratio that we can work with. So what we're going to say then is if we had 100 grams, how much would we have of each of these three? Well, then we would have 37.7 grams of sodium. We would have 23.0 grams of silicon. And we would have 39.3 grams of oxygen. All right, now I'm going to change this so the color matches. Now, the only thing we know about all of these that we can work with is what we can find on the periodic table. So what we can do is we can look to the periodic table and see that if we were to have a ratio to relate them to one another, the only thing we can use again is the periodic table. So what we're going to say is that if we had 1 mole of each of these, how much would we have in terms of mass? And we can get that by the number on the bottom on the periodic table. So if we had 1 mole of sodium, we see that sodium's molar mass is 22.990 grams of sodium. So this is just like when we pulled the mass and called it AMUs. This is the reason, like I said, that this mass on the periodic table doesn't have a unit. It's because we can use it for a couple different things, because it's going to be used for our conversion factors here. So the next one we look at is if you have 1 mole of silicon, how much do you have? Look at the number on the periodic table under silicon. And you see that's 28.086 grams of silicon. In oxygen, if you have 1 mole of oxygen, you have 15.999 grams of oxygen. All right, now for each of these, we're going to multiply and divide. Multiplying by 1 doesn't change anything. So we're going to take 37.7 grams and divide it by 22.999. So 37.7 divided by 22.99. This is where I want you to pull out at least 5 digits. That way we have enough to make sure we get within a tenth if it works. So 1.6398. That's moles of sodium, which is the SI base unit for amount of substance. And make sure you make your decimals really obvious, because it's easy to miss your decimal later on. 23 divided by 28.086. And we get 0.81891 moles of silicon. 39.3 divided by 15.999, and I get 2.4564 moles of oxygen. All right, now that we have these numbers, we know that this is the ratio. So if we were to write these out, we'd say sodium subscript 1.6398, silicon subscript 0.81891, oxygen subscript 2.4564. But that doesn't really work. Remember, when we write empirical formulas, those have to be whole numbers. So we've got a few math tricks to get these into whole numbers. And all we need to do is, if we want to figure out how many times bigger each one is than the other. So the easiest way is to take the smallest one, which is silicon, and divide all of them by silicon's amount here, 0.81891. divided by 0.81891. 1891. Okay, so this one's going to come out to 1, and then we'll figure out how many times bigger the other two are. So the first one, 1.6398 divided by 0.81891. And I am within a tenth of the number 2. It has to be within a tenth. And it's 2.00, so that counts. And I mean, the squigglies there means that I'm saying it's approximately equal to. Alright, now 2.4564 divided by 0.81891. And 2.999 comes within a whole number of 3. So then that ratio for that empirical formula actually becomes Na2O1, S1 Si1O3. Now when it's 1, you don't have to write it. So Na2 SiO3. Boom. Remember, work left to right in the periodic table when you are writing those. Alright, let's set up the next one. Alright, so they're not telling us how much of it is chlorine, so we're just going to take 100%, so 100, and subtract the 12.12 and the 16.16. We get 71.72. Alright, now our conversion factors, just like always. Alright, look to the periodic table. We know that 1 mole of carbon is going to have 12.011 grams of carbon. 1 mole of oxygen is 15.999 grams of oxygen. Chlorine, I think it's 35.453, but let's check. Yep. 1 mole chlorine, 35.453 grams. Alright, now like I said before, even though we know these are really close, we're going to actually divide them out. That way we can be certain it's within a tenth. So this first one, we probably have a good idea of what might happen here. It looks to be about an easy round. First two, 12.12 divided by 12.011. And it is in fact within a 1. Within a tenth, 009, but remember, pull off 5 digits, 1.009, 1 moles of carbon. Alright, 16.16 divided by 15.999. I get 1.0101 moles of oxygen. And then 71.72 divided by 35.453. And I get 2.02295, so then it's 30 moles of chlorine. All right, so then we're going to divide all of them by the smallest. Like I said, you probably could have predicted an estimation here from the start, but let's make sure our numbers come out to be within a tenth like they need to be. The first one I'm not going to bother because obviously that's going to be 1. But let's see if 1.0101 divided by 1.0091. Yeah, very, very close to 1. And 2.0230 divided by 1.0091. And very close to 2 like we probably predicted. Now remember, left to right in the periodic table, the exception tends to be if they are carbon and hydrogen are involved. But for this one, let's just go left to right in the periodic table. So it's going to be carbon and, I wrote carbon both times here, this is chlorine. So it goes carbon and then oxygen and chlorine. So carbon has a 1, oxygen has a 1, and chloride is a 2. Just left to right in the periodic table for this one is fine. Alright, a compound contains 21.1, 6.1, 24.2, and 48.5. If you keep it really quiet, okay? Now we just look at the periodic table, so 14.007 grams of nitrogen, 1.008, I believe is what ours says here, yep, grams of hydrogen, and sulfur is 32.066 grams. So then we're going to divide those out. I was just trying to be efficient here. I can delete those to make it easier to see. Alright, so 21.1 divided by 14.007. Oh, I think this might be a good one. Number 5 digits, 1.5064. Alright, 6.1 divided by 1.008. 6.0516. 24.2 divided by 32.066. $48.5 divided by 15.999. Alright, now we're going to divide all of them by the smallest. So here's our smallest. 0.5064 divided by 0.75469. Oh. 1.5064 divided by 0.75469. Alright, we get approximately 2. That's within a tenth. 6.0516 divided by 0.75469, and it's within a tenth of 8. And 3.0314 divided by 0.75469, and it's within a tenth, and it's 4. Alright, so now we're going to go, I'm going to start with just the order they have first, and then kind of look at it here. So N2, H8, SO4. Alright. There we go. That is why I was staring at that one for a minute, is because to me it looks like you have definitely sulfate, you can see that. But if you see N2H8, I hope you can possibly see it looks like NH4, but there's 2 of them. Okay, so that's what that formula actually was.